Hi, welcome to Teardown Tuesday. You've seen this on the mailbag in a previous video. It's the Cypres parachute emergency release system. So, if you're parachuting, you get knocked out, or you're just too busy enjoying the view, and you forget to pull your chute. If you get to 700 feet or so, if you're going fast enough, this thing kicks in, blows a pyrotechnic charge through a cord, and boom, releases your parachute. And this should be quite an interesting device. And I thought we'd tear it down. It could actually be a little bit difficult, but I expect there to be a whole bunch of interesting stuff in here. At least it's well engineered, because this thing's got a 10-year lifetime, pretty much. You change the battery every couple of years, 10-year lifetime, and it should be built to, an excellent standard in terms of shock, vibration, moisture ingress, all sorts of stuffs. So could be really interesting. Let's check it out. And thanks to Stephen in Carlsbad, California, who sent this in again. And here's the pyrotechnic charge, by the way. A lot of people said be quite careful with this, because it could go off with quite a hell of a bang, and it's one-time use only. It's got a little cutter in there, so presumably when you apply a voltage on there, it's got a neat little sort of like a phono type connector system here, and hopefully, well, let's plug it in, and no, it's not going to go bang on us, but that looks quite robust and quite rigid, but you can actually disconnect that, so there's no it does still have the battery inside, so there's no risk of it going off now. But little cutter in there, pyrotechnic charge, it fires the blade up through there, which you put your nylon cord through, and it slices it, and that releases your reserve parachute. So let's have a look at the unit itself, and it looks like it's got a battery compartment on the top here. You're supposed to, I think it's, where does it say? It's made in Germany, of course, and it was checked in 2007, and it did have a battery change sticker on it. There it is, last battery change, 10th month 09, so, and it still works. So presumably you only have to change the battery every couple of years. You set it once, basically at the start of the day before you go parachuting. You turn the thing on and it just sits there waiting. There is should be some sort of sensor that senses the air pressure and your rate of fall. Maybe there's an accelerometer inside or something like that. And if you're going fast enough at a low enough altitude, under 700 feet, and you're going above a certain speed, bang, it ignites the pyrotechnic charge. So let's open this thing up and take a look. It's got a battery in here, probably a lithium, of course, because this thing's got to work over temperature extremes. It's waterproof, so I'd expect it to be water sealed or hermetically sealed, the electronics anyway. So it could be, hey, there we go, yep, primary lithium batteries. That's exactly German. I'm assuming they'd be lithium. I'm pretty darn sure they would be. And look, there's some sort of sensor in there. Is that a thermocouple or something measuring the battery temperature? I'm not sure what's going on there, but that's exactly what I would have expected. Same with like GPS units and things like that are designed to activate once and then be used long term. They've got lithium primary batteries in them. So yeah, there we go. Okay. So, okay, that's interesting. Check that out. There's the battery connector, and okay, so you slide that in. Yep, that goes in there like that, and there too. Well, they're actually Cypres branded. Where are we? AirTech safety system. So they've actually had them made for them. Doesn't actually say, because it's there. It is. There's the little matching symbol. They've got it specifically branded batteries. It looks like we have a fuse there in series with the batteries, and up here this has got to be, there we go. It's a cap. There you go. So much for a thermocouple. It's an axial capacitor. Go figure. Why have they, that is bizarre. Why have they put an axial capacitor in there? What is that? It's a 10 volt axial cap. Can't get the reading on there, but yeah, that's weird. There you go. Anyway, that's it, and it looks like it is sealed around there. I see some silicon sealant around that, so they've completely yeah, it's hermetically sealed. You can see it around here. It's actually been sealed, so this is going to require some percussive maintenance to get apart, I suspect. We'll measure the battery here. It should be 2 lithium primaries in series. Bam, there we go, 7.3 volts. We have a warning here, do not remove seal. Okay, I won't remove the seal, I'll just break it. Ta-da! Warranty void. And this is weird. This is where the this is the connector for the Pyrotechnic charge, and for some reason it's like got a separate little compartment here. So let me try and wiggle this thing off. It's rather unusual. Well, that's rather strange. It's a 4-way connector there with 2 wires, and there's going into just this little back shell thing here with a silicon adhesive on the wires there for some strain relief. I'm assuming there's some surface mount, a couple of surface mount caps in there, so they're probably to you know, keep out any noise, or possibly ESD or something like that from, I don't know, setting off the Pyrotechnic charge perhaps. And it's all shielded, of course. There's a shielding wire in there, and it's all, yeah, why they've gone to sort of that trouble, it beats me. And it is a shield, a fully shielded case here. Of course, you know, you wouldn't want it to be set off by somebody's, you know, radio, or you know, something like that, or you know, if they've got in-air radio talking to each other or something else, you certainly wouldn't want the thing to go bang on you. That would ruin your day. So it's weird. It's a metal can, some sort of metal shielded can, like foil shielded, I think. Yeah, looks like it's foil shielded with a plastic over the top. So we're gonna might even have to get out the Dremel, maybe. I love the smell of Dremeled plastic in the afternoon. Ah, wonderful. F for fail, perhaps? I don't know. Yeah, the plastic popped off there, and we're left with our metal shielded can. Ta-da! So, looks like we're going to have to get into this sucker as well. Oh man, rather interesting here. This looks to be like a flap that lifts up. So I'm going to desolder that. That pops off real easy. There we go. Ta-da! Hey, look at that. We have some configuration jumpers. And those jumpers would, of course, you know, let them manufacture this thing, completely shield it, and then presumably do configuration afterwards. I don't know what type of configuration. Maybe it's the you know, the level that it goes off at, or something like that. You know, maybe they have different models. Yeah, actually, I think they do. They have different models that go off at different levels. You know, based if you got like a single jumper or a tandem jumper or a student jumper or whatever. So no pun intended. They changed the jumper switch based on the jumper. Now we could try and desolder this all nicely, but really, I think we're better off just prying and then cutting the damn thing open. Hey, oh, look at that. Potting compound. Wah. So, yeah, I mean, you can just cut these things open. I mean, there's no, don't use your good side cutters, by the way. Use your cheap one hung low ones. to do this, but yeah, we have potted electronics in there. There it is. Boing, boing. Yeah, it's oh, hang on. No, hang on. Hey, no. It's just like an outer layer of potting or something. Anyway, let's finish this off, cracking it open and see what we've got. And I'm starting to see pressure sensor. There it is. Classic style of pressure sensor. It'll become clearer once we open this thing. And here it is, minus its metal can, one big sticky, gooey mess of easy entry potting compound. It's not solid potting compound, but it's this really, it's called re-enterable potting compound. It basically, I've used this stuff before and it's really neat because you can actually seal stuff, but then afterwards, after it's sealed, you can penetrate it with a screwdriver and you can get in there and you can adjust pots and things like that and then pull it back out and it'll reseal itself automatically. So that's why it's called re-enterable, because you can re-enter it and then it self-seals. It was, gee, a long time ago I used this stuff, but it's really neat. It really is neat stuff. And they've put this mylar wrap around the... Oh man, how gooey and that is, that's really, yeah, this is just as I remember this stuff, really sticky. So they've put these mylar type sheets or whatever they are, Kapton or whatever, on between the circuitry and the boards and the metal can, so that the metal can can't short out the electronics. So if it gets crushed or anything like that, it's still going to survive and not short anything. Oh man, this is yeah, it's as horrible as I remember. Terrible stuff. Terrible, terrible, terrible. But so that's in there. That's all protected by that, and then they've gunked it all up. This is a real fascinating. They've gone to a bit more trouble than I had envisaged. This is great. It's like pulling, cobwebs off something. It's so we've got one main PLCC device here and another SOT. Oh man, this is going to take forever. Yucko. There's our crew. We've got a real-time clock. Crystal, 32 kilohertz watch crystal there. The main oscillator, the main crystal there for the oscillator for whatever that device is. There's the pressure sensor. It's the classic port type there, and they've just used, an off-the-shelf one. You can see why it's how it's got that ridge on there. It's designed to have like a tube go over it. So they've, oh man, this is great. Oh. Hours of fun and enjoyment, this re-enterable potting compound. I'm telling you, get some. It's brilliant. I can't remember like the brand of stuff we used to use or the brand and model of the re-enterable stuff, but it's exactly the same. Has the same sticky consistency after it's set. I think it was a two-part stuff, and yeah. We use this for where, like, we had to adjust pots and things after, well, we had to potentially adjust pots after it was all sealed. So, yes, well, it's a two-board construction. They've got 0.1 inch header soldered directly on there. Looks like there's no socket there. It's directly soldered across. And that's all there is to it. It's not high-density stuff. I mean, we've got these large... TO220s look like, well, they were TO220s, but they've had their tabs chopped off. I'm not aware of an actual commercial. There's a bit of mylar insulation as well between these devices, so these tabs don't short out, presumably. So they've put that all the way down in there. They put some on the back as well against the connector, but I don't recall there being a package like that with a half moon chopped off. It certainly does look like they've chopped off the tabs to make this fit. And you can see them, they're clearly being chopped off all right, and I wonder who would have done that. Even the manufacturer, they probably wouldn't have had a bar of that. The actual device manufacturer themselves, I don't know, maybe you could order them with half of their tab chopped off, but more likely done at the assembler or something like that. They would have designed a jig to chop that off without putting much physical strain on the device at all, so you don't affect the long-term reliability of the device. But there you go, it's rather interesting that they've gone to that much trouble. Presumably, of course, the big power devices are for firing the pyrotechnic charge, which I assume requires probably a substantial amount of current. I don't know. I'm not into firing the circuitry required to fire pyrotechnic charges, but that would be the only reason why you'd have large power devices like that in such a device. And of course, with the jumper there, you'd have to be very careful that you like gunk this after you've put that jumper in place, because you wouldn't want to get a bad contact on that because you slid it over some potting compound. But isn't that wonderful? Oh, it's great stuff. I love it. Oh, I'm going to have hours of fun with this. Now, the other really annoying thing about this is that there's a whole bunch of circuitry on these boards in here, on the on the other side of the board. So to really do a proper teardown, I'm going to have to desolder. I'm going to have to clean off all of the gunk and desolder these boards. That's really rather annoying. And these pressure sensors, they're available in several types. One is the absolute pressure sensor, which measures the difference between the pressure on the port and an absolute vacuum inside. Another type is the differential pressure sensor. These will have two ports on them where it measures the difference between one pressure and another. This is obviously not a differential type. In that case, it's most likely a gauge sensor, which measures the pressure coming in the port to the ambient pressure. And there was something in the manual, I don't recall, I'm not going to check it, about this thing, being set to ground pressure, and then it continually samples against, I think it continually samples or something like that, to take out the effects of air pressure changes. And of course, I think desoldering this thing is too much of a pain in the butt, so easiest way to do it is to just get in there. Thankfully, they've used 0.1 inch and cut all of these pins all the way around this thing, and hopefully we can pop the two boards apart. Almost there. Oh, this is just so unelectronic, it's not funny. Hey, ta-da! Oh, we finally, there was an extra bastard connector in there or something, was it? That's what was causing the problems. We have a Maxim device, and bingo, we're in. The main thing that strikes you here is just how old school this design really is. I mean, there's a Motorola MC68HC68 real-time clock chip. There's the real-time clock crystal there. We've got just a 7.4 series gate there, and this, I can barely make out the number on it, but it's definitely a Motorola ZC4 something or other. Well, it's definitely a microcontroller slash processor, or definitely a microcontroller, because there's no external memory on this thing, but can't quite make out the rest of it. Unfortunately, there's some crap and gunk on there, but yeah, it's some sort of old school Motorola, which is now Freescale processor on the thing. And on the back here, it gets even more old school. We've got a Maxim ICL 7109 in a PLCC package like that. That is a 12-bit ADC for sampling the pressure sensor, of course, and really, incredibly old school stuff. So it's based on a legacy design. Maybe they've had this design around for 15 years or something, and they just haven't bothered to upgrade it. Really, I don't really blame them, because you probably have to get this thing qualified and all sorts of things for in terms of a critical application like this that saves people's lives. So it's probably all coded in assembler, and they would have maybe had to get all the source code approved like they do in intrinsically safe and other products and stuff like that. So and other life support applications. So a couple of caps here with the leads bent over, very sort of hackery kind of stuff. And it just looks like we've got some old style MELF resistors here and a LT1079, which is a precision op amp. So that's all that's on that board, an op amp. So they've got some gain and stuff. They've got the ADC, and they've got the processor with, old school processor with a real-time clock, and presumably that's a voltage regulator over there for that, but yeah, not much else. And on the back of the board here, they've got an LT1020, which just is just a positive voltage regulator. And check out this bodge up here. We look at these MELF resistors soldered in, and this package over here, I don't know what that is, but they've obviously decided to bodge that in. There's another bodge here with another 100N cap, and is that a diode in there? Anyway, that is bodge central, really. And but they've decided that these are all probably they're all handmade. They're not produced in massive volumes. They're probably produced by the thousands or something like that. They're certainly not produced by the millions. And they've got a couple of electrolytics on this board. They're 105 degree rated. They would be absolute primo prime spec. This is a high reliability device, 10-year lifespan. I'm surprised they used electrolytics in here at all, actually, but I guess they deemed they had to in that particular location. Now, let's take a look and see if we can figure out what these TO220s are. Probably just some power transistors. And you're able to just see that marking in there. It's a BUK455, which is a power MOSFET. No surprise. So they're clearly using those to maybe in a H-bridge configuration, who knows, to drive the Pyrotechnic firing device on there. So there you have it. There's the Cypres, made in Germany. Hi to all my German viewers. Parachute emergency deployment system, or whatever it's called. Anyway, it was rather interesting. Pretty much exactly what I expected in there. It was just a pressure sensor with a microprocessor in there. Really, there's nothing else in there. There's no accelerometer or anything like that. So obviously they're clearly just using the pressure sensor to detect the height. And really, okay, it's like it deploys about 4 seconds before you hit the ground. So, well, obviously they've done their testing on this thing and determined that it's good enough. It does the job. Well, I haven't sat down to think about it. I'm not entirely sure how the pressure sensor was working in such a sealed, a reasonably well sealed enclosure like that. Anyway, they are able to get this sucker to actually release, 4 seconds before you hit the ground, and it's got to be ultra reliable. People's lives depend on these things, and people's lives have been saved by this thing, by it firing at the right time. So if you got any better ideas on exactly how they've implemented this possibly, jump on over to the forum and discuss it.